Good morning everyone. Today we're going to be taking a look at this procedural flag animation setup. I developed this when I was working on a show that had a big cityscape, and it needed a load of flags with nice distinct movement for each one. It's also got some wind going on, so from as in the wind speed on the left hand side of the screen is faster than the wind speed on the right, and this is all tunable. So I'm going to cross this out. Let's get started. Laying down a geo node, and we're going to call this one fx_flags. Okay, nice and simple to start with. All we're going to do is create a grid object. We're going to orient it in the YZ plane. The reason we're doing it YZ is, well, for Z, we're going to be copying to points, and I like to orient things down my Z axis. It makes it for nice, consistent copying and positioning. So we're going to say that this is 2 units wide by 1 unit long, or 2 meters by 1 meter. And there it is, happy little flag. We're going to give it 100 rows and 200 columns, so we've got enough geo detail to represent what we're creating there. Okay, we're going to be doing a lot of UV based stuff, so we're going to throw down UV texture, and because it's a grid, we can happily just use the orthographic projection and project it down the x-axis. If you press space 5 over the viewport, it will show the UVs, which is perfect. That's exactly what we need. Cool. The only thing we need to do other than that is set these to point attributes, because we're going to be doing a lot of manipulation using these UVs. We're also going to just quickly move this along a unit in Z so that it's sitting nicely at the origin there. Cool. So one of the features that I want to add is make it look like it's pinned at either corner, so the flag is bowing out from this location. So let's do that. So laying down an attribute VOP. We're going to plug this in here. I'm going to call this AV curve. So we're going to take the UV Y component and use that to add to point position in Z, but this could happen after rotation. We don't know what orientation the flags are going to be in, so we're going to do some funky stuff with normals and a cross product to calculate that. So if I create normals on this, and I set these to point normals, again we're operating in a point context, you can see the normals are pointing that way. And we're going to go inside and do a cross product with these to figure out the direction tangential to the surface. So we'll do a cross product, and we're going to plug that into N. I'm going to set that to the up, which is 0, 1, 0. Perfect. Okay, so we've got the cross product and we've got this UV component. Now what we need to do is we need to do a ramp on this. We'll call this a V ramp because it's the V component of UV. I'm going to set this to a spline ramp. Okay, and then we can go add. So because this is adding this ramped parameter, by default it's going to be it's just going to move everything along by a single unit because we've not done any multiplication yet. So if I plug this in, everything will just move along in space a little bit. So if I throw in a multiply just here, and then wire the ramp into the second input, everything goes back to 0 because the ramp has defaulted to a flat line when we changed its type. But if we do this, we'll see the magic happen. Ooh, There we go. That's not exactly the shape we're after. We want something a little bit more like this. I'm going to put this at 0.25 and this one at 0.75, so it's nicely symmetrical. And let's just shift click all of these and set them to B-spline. And there we go, we've got some nice curvature. Although you could say that that's a little bit big. So what I'm going to do is I am going to, on this multiply, I'm going to promote this parameter. And I'm going to call this curve mult. Curve mult. And let's put it to a default of 0.5 so we can see something happening. So we've now got artistic control over that. But it's static. I don't want it to be just static. I would like it to have some animation. So we could use sine waves and multiply sine waves, but it's a bit of a pain in the neck. I am going to use anti-alias noise, because anti-alias noise can be used for almost everything. I am going to be plugging time into here. I'm going to have a multiply just here. And I'm going to promote this parameter and call this animation speed. Cool. Okay, well, again, we're going to default that to 0.5, just so we've got something in there. Okay, so I know that an anti-alias noise with an amplitude of 1 and a roughness of 0.5 returns values between negative 0.35 and 0.35, more or less. So what I'm going to do is I'm going to put a fit range. And I'm going to fit this from negative 0.35 to 0.35 to 0 to 1. And then if I plug this into the multiply, we should get some animated movement going on. There we go. Perfect. So that looks like wind tugging the flag a little bit. I'll just promote some parameters. I'm going to promote frequency. I'm not going to bother with offset, we don't need that. I'm going to promote the, not the amplitude, the roughness. That should do everything we need. Cool. I promoted a subnet input by mistake. Let's just delete this, and there we go. Okay, so what we might do is just reduce the roughness, turn on real-time playback. Yeah, it's a little dull. Let's increase this to 1. Cool. And I'm just going to tweak the ramp slightly. I'm just going to add a little bit of corner pinch here, just to make it look like there's some little bevels or something holding that ramp in place. Excellent. Right, and now what we want to do is we want to now copy this onto a load of points. So what we're going to do is we're going to create another grid. We are going to say that this is 25 by 25 units, and we're going to say it's 4 by 4 in rows and columns. And if we just copy to points straight away, and we do it here, here, and then plug this into here. Cool, you can see it's gone a little crazy. So what we need to do is we need to set the up and n values on these input points in order to have them work correctly. We don't need an attribute fop, we need an attribute wrangle. And we're going to call this attribute wrangle copy attrs. So very simply, I'm going to say v at up, so that's a vector called up, equals set 0, 1, and 0. And then I'm going to say v at n equals set, and I want this pointing down the z-axis, so it's going to be 0, 0, 1. And with a click, everything's doing what it should be. Cool. Okay, now the only problem is These all have exactly the same amount of movement. The animation's in exactly the same place with exactly the same time. It's a little dull. So what we're going to do is we're going to create an ID attribute on the points. This then gets stamped onto all the copied objects, and we can use that to create some variance. So attribute wrangle ID, we've done this one before, I at ID equals I at PT num. And then if we go to this curve, VOP, we can bring the ID in and add it to time. So now everything has got a slightly different offset. So you can see everything's moving in a slightly different way, which is exactly what we're after. Perfect. Cool. Okay, so we've got that going on. Now just to show you the reason why we might want to push this along across productig normal as opposed to just saying it hard-coded in Z, we might add some rotation to these so they're not all pointing down the Z-axis. We might want some bespoke control over that. So we could do this in the copy atters. We could add a randomization, but you know, a lot of this is about using anti-alias noise. So we're going to create an attribute VOP. I'm going to drop it down. Inside, I'm going to create an AA noise. I'm going to base that just purely on P, just for ease. Let's promote that to parameter, and amplitude, and roughness. Okay, now what we're going to use this noise to drive is a rotation. We are going to rotate the normals around an axis. So put a rotate node down. So I want to rotate them around the vertical axis, so 0, 1, 0. And I am going to multiply the normal by the output of this matrix. If you want to apply a matrix to a point position or a normal, use a multiply. So let's do that. And then plug this into N. Now, at the moment, we can just start scrubbing this and rotate things around. We want some variance in there driven by this noise. So what I'm going to do is I'm going to say constant. I'm going to call this 360. I'm going to say degrees to radians, because the rotate node operates using radians instead of degrees. And then the output of this I'm going to multiply by the value of that noise. So input 1, input 2, and there. Excellent. So why have we done it this way? Let's go up, have a look. The advantage of doing it this way is that we can now, if we have a direction we want this noise to travel in, say for example along the Z-axis, I can start offsetting this noise in Z, and that noise travels through that Z-axis. If you want more or less rotation, you're going to be playing with the amplitude here, so just bringing that down will bring everything a little bit more in line. Let's have a look and see how they are moving. I've not added any animated values, so let's say $T. Let's see how that moves. So it's a little bit jerky, a little bit flappy, so I'm just going to reduce the roughness on that to smooth it out. I am going to increase the amplitude ever so slightly. Cool. Nice. So we've now got this animated push value and this animated flapping, which is excellent. I'm going to have a little bit more animation speed, I think. Just a little bit quicker on the anim speed. There, a little bit more visible. Okay, right, next thing, let's try and make this actually look like flapping cloth, which is the fun part. Okay, we're going to create another attribute VOP. Going to call this AV noise. I'm going to call this LF for low frequency. And just visualize that. And just so we know that we're visualizing a good output, because the normals all get recalculated here, I'm going to just recalculate the normals just at the end here. Okay, with the normal in place, dive back inside this attribute VOP, and if you hadn't figured it out already, we're going to create an anti-aliased noise. We are going to plug not the P into there, we're going to plug in the UV values. We want this to be a 3D noise, and we want to add to P. So let's do that. Oops, add, not AV. So here we go, plugging that in and into P. Cool. So it's a little high frequency there. What I'm actually going to do is I'm going to bypass this copy to points, just so I can fine tune this on a single flag. Super. Going inside, we're going to promote the noise parameters, so frequency and offset, amplitude and roughness. Now, one of the things that we'll immediately need to fix is that at the moment the corners of the flag are no longer pinned, so they'll move as the noise moves. So if I just add a little bit of movement, there we go. You can see that the noise moves through the flag, but those corners are moving way too much. Okay, so back in the attribute VOP, we're going to do a vector to float, because we're going to be using a few of the components of this UV vector. I'm going to grab the U and ramp this one, and we're going to call this the U ramp. And set it to spline, and then before the add, we're going to add a multiply. Cool. Okay, as always it defaults to being flat as a pancake, but there we go. We've got this nice noise moving through. Now what I'd like to do is I'd like to add a little bit more curvature. You can already see that we're getting some stretch that goes with this, how we've deformed the geometry more, but I want to really emphasize that. And I want it to be independent of this movement here. I want it to really look like the wind's catching the center of the flag more than the edges. So we're going to create another ramp. I always do this. I really hate this ramps node. I've used it so many times and never actually intended to. Ramp parameter. Throw it in there. Call this the V ramp. Set it to spline. Grab this component. So what we're going to do here is we're actually going to manipulate this UV space. So instead of using the uniform space that we have, we are going to add on to the this U value with this ramped V. So add, take that, plug it in, take that, plug it in, and then we can use set vector component to set that first component. There we go. Okay, so let's go and see how we can use this. So if I start pushing this ramp, you can see we can start manipulating the space a bit. If I do what we did before, so let's say 0.25 and 0.75. So you can see that these ripples are actually all going the opposite way to what I want. So what I need to do is I'm going to go in, I could use a subtract here instead of an add, but I might be adding more things later. I'm not quite decided. So for the time being, I'm going to use a negate to invert that motion, that size rather. And what we're going to do as well is we're going to add a multiply, because the scale of this movement is a little bit too big at the moment. So in between the negate and the ramp, It could go after, it doesn't really matter. The order is fine when you're doing multiplies. And let's call this curve size, curve size. Cool. Okay, so now we can start pushing that along, and it just gives a little extra bit of stretch to that motion. What I might just do is just bring this in a little bit and add that there. Excuse me. Okay, set this to B-spline. Cool. Okay, so now we've got that extra little bit of curvature to give us some more interesting motion. But, you know, this doesn't look great. It doesn't necessarily look like cloth. So what I'm going to do is tune that noise. I'm going to turn the roughness off entirely. So let's take a look at what that looks like. Yeah, that's a little bit better. We're getting that nice gross movement. This is the high frequency noise. So that is what we're after all. And so what I'm going to do is I'm going to set this to 2 because I want a few more ripples in that direction. Maybe even 2.5. Oh yeah, look at that. That looks great. And then I'm going to set this to 1.5. Okay, that's not bad. It's a little bit slow how it's moving. And this brings up an issue that occurs when you're working with noises and you're animating them. So by using this offset, it is dependent on the frequency of what speed it's going to be moving when you apply it in space, especially when you're using things like UVs. So what we can do instead is get rid of that, set that to 0, and instead of changing an offset, we're actually going to move the UV space. So this is where this second add comes in. What we're going to do is we're going to promote this parameter, and we're going to call this anim position, and we're going to go up and we'll set this, let's start off with something like $T, see what that gives us. So this is going backwards, so we need to negate that. Maybe I should have just used the subtract node there, hey. But hey, that works fine. So that's a little bit better, and the thing to notice is that we can change the scale of this noise, and it's going to be moving at the same speed, which is super useful. Okay, so let's just have a little look. I think that's probably mostly what we need to do at the moment. Okay, I'm just going to, I think I can leave the amplitude as it is. One thing to note, one of the reasons I wouldn't want to use this on close-ups is every now and then, as the amplitude gets bigger, you do get some interpenetration just there. Whilst you can get away with that when it's, you know, that big in screen, when you get close-up, it's not ideal. But let's go with this, and we will turn this back on, and let's see what issues we can note. There we go. We've got the issue that everything looks the same because we need to have something to differentiate these flags. We've already got it built in. Let's just wire it up. Okay, so what we need to do is set another vector component. This time we want to set the third vector component, and we want to set that to respect ID. As soon as we plug that in, everything gets a different offset of that noise. And we've got variance. Cool. Obviously a bit slower to cook now, but you know, this is procedural. You kick it to the farm and it all comes back almost instantly. Right, let's have a little look. The thing that we've got to do now is I want to apply that wind speed setting to these. So at the moment, all the noises are moving at the same speed, all the amplitude's the same, so it's all like a bit identical. So we're going to create an attribute to influence that. I'm going to do this up here so it stamps down through the geometry. I'm going to plop it there, and we're going to call this attribute wrangle wind mult. Okay, so I want to be able to draw a shape, and the wherever is closest to it will pick up the fastest speed, and wherever is farthest away will pick up a slower speed. So let's do that. So I'm going to create a curve. Just turn on grid snapping. Oh, it's already on. Happy days. I'm just going to draw a curve like from there to there. And I'm going to resample that to make sure it's got plenty of points. Plug that in. Cool. Okay, first thing we need to do is we need to tell this wrangle to find the nearest point to itself. So we're going to use the vector command of near point. So if we say int near pt equals near point 1 v at p. So the 1 is just telling it to look at this this input here, the data stream number 1. Okay, so we've got that. We've got the near point. Now we need to find out the position of that point. So we can say vector pos equals point. So this is how we look at point data. We're looking at geostream 1. We want to look at the attribute by the name of p, and we want to look at the point number of near pt. Cool. So we've got the position. Now let's find the distance. So float dist equals distance, and I want to find the distance between pos that we've just found out and my current point position, which is v at p. There we go. So now the thing that we've got to do is we've got to fit that distance, which could be completely arbitrary. We know it's probably going to be somewhere between 0 and 25 in this instance, but it could be anything. But we need to fit it into something more usable. Let's say 0 to 1. So if we say float fall off equals fit dist from CHF min dist to CHF max dist, and I want to remap that. So the min dist I want to equal 0 because I want that to receive the most wind, and the max dist I want to be 0, so it receives the least wind. But obviously I don't want anything to receive exactly that value. So what I might do then is a follow-up fit range. So I might say f at wind mult equals fit 01. Fit 01 is really useful because it assumes that the input value is between 0 and 1. And I'm going to say fall off and say CHF min mult and then CHF max mult. Cool. Okay, so if we hit plus on that, I'm going to set the min and max. I'm going to set the min to 0. Why not? Don't need to change that. Max to 25, so anything over here should be receiving max. I'm going to say the minimum mult is 0.75 and the max mult is going to be 1.25. Cool. Okay, let's just check the data, make sure that's doing what we expect. Yeah, we've got 1.2 to 0.75. Perfect. Right, following that, we need to implement that on everything. We'll start off by implementing it on the curve. Okay, so we want to influence the speed and the amplitude. So we need a few multiplies. So we have here, this is the speed input. So I need to multiply time here by that input. So if I throw a multiply down, plug it into this time output, and I'm going to bring in that wind mult. So bind, I'm going to call this wind mult, and it is a float value, so that's fine. Plug that in there. And I'm also going to plug it into the output size. So I just need to plug it straight into there. I could just wire the same node over, but I don't like it when nodes all cross each other over. So paste another multiple of it in there, and there we go. Cool, so that should be working. We should have the ones over here receiving the maximal and the ones over here receiving the least. If you want to check that that is the case, you can set the min mult to 0, and you should see all these completely lose that curvature, which we do. Happy days. And there we go. Right, so that's influenced the speed of the noise, so it should be pulling slower and it's being pulled less. Let's do the same down here. Okay, so we want to influence that that speed that we're working with. The speed is being controlled here with this animation position. So I'm going to bring that down. Let's just reorganize this slightly. Cool. And I'm going to throw down a multiply. And then let's Control V, because I've already got this copied, and wire that in. So that's the speed taken care of. Now let's take care of the amplitude. We already have a multiply here which controls that amplitude, so Control V and wire it in. Let's just check the normalized version. There we go. Cool. Again, if you want to check that this is working, select that. Let's change that value to 0, and those at the end should flatten out. Cool, but obviously we don't want to do that, so there we go. Okay, I'm going to just do a couple of tweaks to the setting here. Let's turn it to a dark background. I'm also going to turn off, where is it? Oh, tint back faces is already off. Happy days. Doesn't look like it's off, does it? That very much looks like tint back faces is on. Oh well, I guess we can live with that. Okay, so there we've got the flags. I'm going to turn off the grid, and I'm going to flipbook this, see how we're looking, and see what we want to do to it next. Catch you in a moment. Okay, decided this was enough frames for us to be going on with, and this is not looking bad at all. We've got this nice sort of bouncy animation going on here where the flag is attached. We've got the nice ripples moving through, and you can see clearly the wind speed is taking effect. The thing that I want to do now is add a bit more high frequency detail, because this is a little basic. It's probably enough, to be honest, for most instances. You've got the gross movement, you'll be able to see this from a distance. But let's add something a little bit more high detail. Fortunately, we've already done the whole setup that we need to in order to achieve that. We've got this low frequency noise. So if we paste this in here and rename this high frequency, let's change some values, see what we get. Okay, so for this one, what I want is I want slightly different shapes, so I want the Y component to be higher than the X, so we get sort of stretched out shapes. So I'm going to set this to 5, and I'm going to set this to 3.5. And I'm going to have a little bit of roughness, just a tiny bit, and I'm going to increase this amplitude. Where should we set it? Just there. So just A-B with and without. Yeah, it's just adding a nice little bit of extra detail. And I think just to add a little bit more variance, I'm going to change the animation speed so it's slightly faster. So I'm going to say times 1.5, just to make it quicker. Okay, we've made that addition. Let's. I'm going to flip up from this side so the wind's blowing the other direction and I can see the front faces. I really don't know why it's not turned off that tint back faces. Here, if we come up to this level, it's fine. Cool. Okay, let's stick with that, and I'll flipbook this, and we'll have a look at this when it's complete. See you in a moment. Okay, so there we go. We've got some nice procedural flag animation here. The little high frequency noise that you can see, for me, really does add a lot. It really helps sell the fact that it's this is cloth. You can see there's a much more violent animation going on the left-hand side to the right, so you know we can really create some variance. And because this was created by a curve, you could have pockets or corridors of wind. So yeah, really useful. Hopefully you found some of this relevant to the work that you're doing. You notice that I use anti-alias noise a lot. I think it's an amazing noise because you can get a lot out of it, and it's got so few input controls to generate what you need from. I find curl noise, you can get some really cool stuff from curl noise, but there are so many controls, so I don't want to spend hours fiddling with all those controls. So this is what I do, anti-alias noise all the way. Cool. So, yeah, if you have anything that you want to ask, drop it in the comments. If you have any things that you think would make this better, definitely drop that in the comments. Everyone always loves hearing how to make setups better. And yeah, I hope you have a good time, and good night.